Hi guys, welcome back to my YouTube channel. So this is going to be the first video of our series data structures and algorithms. So today I'm going to talk about the ArrayDeque, one of the most efficient and flexible data structure in Java. So let's break it down. So the first thing first, we have to concern about the naming convention. So as you can see, there's two parts, the implementation and the abstract data type. So the implementation tells us how you do it, and the abstract data type tells us what you need to do. And also as you can see, we got the ArrayDeque right here, and you can see the array is the implementation and the deque is the abstract data type. So which means this is a deque implemented by using an array. And also we can define the deque as a double-ended queue. So ArrayDeque is a implementation of resizable array. Therefore it contains head and tail indexes, which means you will be able to insert data from the starting of the array and the ending as well as remove data from starting and the ending. So the ArrayDeque is more like a combination of a queue and a stack. And also there's different ways to insert and delete an elements. ArrayDeque does not allow null values because internally it changes the value as null to maintain its position. And also if the ArrayDeque reaches the end of the array, it wraps around like a circular way. So and also if the array becomes full, then the Java automatically doubles the size of the array. So and lastly, the ArrayDeque is very fast because it uses internal circular array. So as you can see, the ArrayDeque is an underlying implementation of circular array. A circular array is an array that is logically connected head to tail when no resizing is needed. So without a fixed start and end, when array is full, it is resized. So in this video, we are going to talk about two implementation methods, the queue implementation method and the stack implementation method. And before that, we are going to look what is an array looks like. So as you can see, this is an array, and you can see it is starting from the 0. So and also an array contains head index and the tail index. So and also these two also have within the ArrayDeque. So we can store values from any particular point. So let's quickly see how basic deque works in Java. So the first thing is I'm going to create the ArrayDeque class. So after that, you can see the ArrayDeque class also imported right here. Also we have few methods to insert some data like offer and push, something like that. So for now we are going to try the add first method. So I'm going to do is okay, so right here you can see the first thing I have created the ArrayDeque class, and after that I use the add first method to add number 30 as my first element. So we're going to run this and see what will happen, and you can see number 30 is printed as the first element, and I also going to add the number 60 as the last element. So what I'm going to do is and okay 60, and you can see after that you can see number 60 will add as the back element of the number 30. So and there's also one method called add. It will do the same as this the last method, and I'm going to show that to you. So the add method also work as the add last method. So we'll see what happens. So you can see number 90 is printed as the last element of our deck. So we are gonna remove these elements from this deck. So we'll see how does it works. So for that I'm going to use remove first and remove last method. So we'll see what happens. Okay, so as you can see, number 30 will removed because of we call the remove first method, and also we have other method called remove last. We'll see what happened when we call it. Okay, so alright, so as you can see, the number 90 is the last element of our deck, and it will remove when we call the remove last method. So as you can see, this is how the basic deck works in Java. So okay, so right now we are going to do the stack implementation of the ArrayDeque. So which means stack behaves as LIFO, that means last in first out, which means whatever the element stored last will remove first. So we're going to do that using push and pop mechanism. So let's see what will happen. Alright, so as you can see, I'll push 3 elements into our stack. So after that I'm going to print our stack. So let's see what happened. Alright, so as you can see, the elements printed respectively as the rules that follows the stack. So what I'm going to do is I'm going to use the pop mechanism. Okay, so we'll see what will happen. Okay, alright, so as you can see, the last element that we stored will be removed first, and you can see the last element is 3, and you can see in the stack the element 3 will removed. So now we are going to see how it internally works. Okay, so whenever I call the push 1, it will point to the index 0, and the head is pointed to this, which means the index 0. And whenever I push the number 2, the number 2 will print in the number 1 index. Then the head is moved right here, and when I'm called push element for number 3, then the number 3 will printed in the index number 2. Then the head will point to right here. So whenever I call the pop method, it will remove the last element that we stored last. And whenever we did that, this will be marked as null. So which means the number 3 will removed and it will mark as a null. And then the head is pointed to right here, and when also we call the pop method once again, it will do the same as the previous, and when we did this, the number 2 will remove and it will mark as a null value, and then the head will move to right here. So this is how the ArrayDeque works when we implement it as a stack. Okay, so now we're gonna do the queue implementation of the ArrayDeque, which means first in, first out. And remember, the queue behaves as FIFO, which means whatever the element stored first will removed first. So we're gonna do that using offer and pop mechanism. So let's see how it will work. So I'm gonna change the insertion order to offer because we are using the queue implementation. So we'll see how it will work. Alright, so as you can see, here is our queue. So whenever I call the pop method, what will happen? Let's see. Okay, and you can see as the first element we stored the number 1, and the second element number 2, as the third element we stored number 3. And so now we are going to do the pop method. So let's see how it will work. Okay, so as you can see, the number 1 will remove because the queue behaves as FIFO, which means first in first out. Whatever the element stored first will remove first. So we are gonna see how it will internally work. Alright, so these are the methods that we use to insert and remove the elements. Alright, so whenever I offer number 1, which means I insert number 1, it will printed on the index number 0. Alright, so whenever I offer number 2, it will printed on the index number 1. So and then the tail is going to point here, which means whenever I do the offer, it will change the tail position, not the head position. So whenever I'm going to offer the number 3, it will printed on the index number 2, and then the tail position is pointed to here. And so whenever I call the pop mechanism, it will change the head position to next element. What I mean is whenever I call the pop method, it will change the head to next position. Alright, so our first element is number 1, and the second element is number 2, and the third element is number 3. And whenever we did the pop method, it will remove the number 1 and marked it as a null, and then the head is pointed to right here, which means index number 1. Okay, so that's all about the today video, and I hope you all understand the video, and make sure to subscribe and hit the bell button. So see you soon.